Okay, section 7c, the law of large numbers. Now remember, tossing a coin. There's a 50-50 chance, a 1 in 2 probability of you getting ahead. But remember, it may be that you throw a coin, toss a coin a few times, and you only get tails. But of course, if you do it a lot, you keep tossing that coin 1,000 times, then you'll get closer and closer to that theoretical probability of 50%. 50 heads, 50 tails, okay? So again, this is the law of large numbers. Now then, a roulette wheel. 38 numbers, 18 red. Probability of getting a red is just 18 out of 38. Now that comes out to be 0.474 as a decimal, okay? So if you spin the wheel 1,000 times, how many reds? Multiply it by 1,000, you'll get 474 reds, okay? So that's how many times a red is expected out of 1,000. Now, of course, that's less, okay? That means that 526 are not going to be red, which is more for the casino, okay? The odds are better for the casino. The more people play large numbers, okay, the more they're going to win. Right, okay, insurance company. Now, it sells a type of insurance that pays $100,000 in the event you quit your job because of illness. Now then, they've decided that there's probably a probability of 1 in 500 of you actually making a claim. So, if they sell their policies for $250 each, okay, right, they will make $25,000 if they only sell 100, okay? So if you sell 100 policies for $250 each, great, you've made $25,000. Now then, the problem with this is if you pay out $100,000, you're going to lose, okay? If you sell just 100 policies, okay, you get 25,000, you pay out 100,000, you've just lost a lot of money. So of course, again, the law of big numbers, the more you sell, the better it is, okay? So here we go. Supposing you sell 1 million policies at $250 each, that's $250 million, okay? That's what you've got. Now then, here we go. If you sell 1 million policies again, and the probability is 1 out of 500 that somebody will make a claim, that's 2,000 claims, okay? Again, just multiply those two numbers together, okay? So remember, 1 million policies, probability is 1 out of 500, which means you're going to be making about 2,000 claims, okay? Now, paying this out, again, remember, it's $100,000 for every payout, so 2,000 claims at $100,000 each is $200 million. So, therefore, you've brought in $250 million, you've paid out $200 million. Well, that's a nice big profit of $50 million, okay? Now then, at 1 million people, that's $50 a policy, okay? Think about that. $50 million you've made, 1 million people, that's $50 for every person you've just made, okay? Now, that is what's called the expected value, okay? That's what we expect to make for each policy, $50, okay? Now then, instead of doing all this work up here, there's a little formula down here, all right? So here we go. Now, this is how it works. What's the value of event 1? Expected value is the value of an event times its probability, plus the value of another event with its probability. Now, here we go. The events are this, that they are going to get $250 from you, okay? So what we do is here we go. What's the value of the event? It's $250 to the insurance company. And there, for each one, the probability is it definitely happens, okay? They are getting the money from you. And that's why we have this down here. So again, the value of the event is $250 for them, okay? And it's definitely going to happen because you are paying the money. So the value of the event is 250, the probability is 1, okay? So we have this. Now then, we're now going to add the value of the second event. The second event is them paying out $100,000, so they lose $100,000, okay? Now remember, the probability for this was that 1 out of 500. Okay, so there is the second event. Again, the value of it times its probability. Now we just add these two together. Okay, so 250 times 1 is $250. I'm going to add. Now then, this 100,000 times 1 over 500 in your calculators is negative 200. Okay, that gives you the answer of 50, that is the expected value, $50 per policy. So again, just remember this here. We're going to be just a few times because there might be more than one event, or rather there might be more than 2 or 3 events. So the expected value, the value of an event with its probability, and then add on the value of event 2 with its probability. Let's take a look at some of these. Right, here's one. Okay, supposing a dollar lottery ticket, okay, following probabilities and values. So here we go. You win a free ticket here we go. Right, ticket purchase. You have just paid out $1. Again, you've done it. The probability is 1. Okay, probability is 1. So therefore, the value of the event is -1 because you've paid it out, and it's definitely going to happen. Okay. Now then, if you get a free ticket that's worth $1, okay, there's a 1 in 5 chance. So here we go. You're going to get a free ticket. There's a 1 in 5 chance of that. So again, the value of it is +1. You're going to get this, not pay it out. The probability of it is 1/5. Okay. So we'll keep going on. Look at the next one. Right, the probability is 1 in 100 of you winning $5. So again here, if you get $5, the probability is 1 out of 100. Okay, so again, let's look at all of this. If you win $1,000, the probability is 1 in 100,000. Okay, so again, you get this, and this is the probability. And finally, 1 in 10 million to win a million. So you will win a million, but this is the probability. So again, notice how all these are positive because these are you getting it, but you lose the dollar because you've paid for the lottery ticket. Now, it looks like we're going to have to add all this up, and this is what happens, okay? So again, the value times the probability. The value of you buying the ticket. You've lost $1 because you've paid for the ticket, and you've definitely paid for it. You've definitely got the ticket. It definitely happens. That's why it's a probability of 1. Okay, you'll win $1, but the probability is 1/5. You win $5, but the probability is 1/100th. You win $1,000, the probability is 1 in 100,000. You win $1 million, the probability is 1 in 10,000. If you multiply all these out, okay, try it in your calculator, this is going to be for each one. Now again, this is the expected value for the dollar. You will lose 64 cents, okay? You will lose 64 cents, which means the lottery people are gaining 36 cents, okay? And again, but don't forget, the law of averages, over a lot of tickets being bought, they win a lot of money, okay? So you're expected to lose if you buy $1,000 lottery tickets, okay? If you're going to lose, again, 64 cents for every ticket, you'll lose $640, okay? Again, just 1,000 times 0.64. Okay, so I'm going to pause it there. I'll do another video on some other material, and again, we'll come back and look at something like this again.